ReclaimLLM is moving beyond session capture into active memory for AI coding agents. With the new local MCP server, tools like Claude, Cursor, Codex, and other MCP-aware agents can search previous CLI sessions, find work by project or file, retrieve session details, and turn an old session into reusable context without copy-pasting long transcripts. On top of that, ReclaimLLM now ships marketplace-style plugins for agent environments, so memory becomes easier to install, discover, and reuse. The goal is simple. When you return to a bug, a refactor, or an implementation decision from weeks ago, your agent should be able to ask ReclaimLLM what happened before, recover the right context, and continue from your actual engineering history. First, we ask a natural question. Find sessions where we solved auth issues. The agent calls the ReclaimLLM memory search tool, scope to the current project, and returns the most relevant prior sessions with titles, IDs, and short highlights. Instead of digging through old terminals or chat exports, previous debugging work becomes searchable engineering memory. Next, we look for a different session. What about creating templates for emails? ReclaimLLM searches the captured sessions again and finds related work around Supabase email templates, invite flows, SES migration, and transactional email fixes. This shows the marketplace plugin in action. The agent can discover prior implementation context using normal language without the user needing to remember exact session names. Then we switch from topic search to file-based search. We ask what changed around a specific file path. ReclaimLLM finds past sessions that touched that file, and the agent can combine those memory hits with local Git history to separate captured session context from actual commits. This is especially useful when you remember the file, but not the conversation or decision that led to the change. Finally, we select one of those sessions and summarize it before restarting or reusing the context. The summary brings back the task overview, root cause, key decisions, modified files, and pending follow-ups. In this case, debugging VS Code hook logging and path issues. That summary becomes a compact handoff, so the next agent can continue from the real history instead of rediscovering the problem from scratch.